Hi, this is a recorded lecture for the IB DP Design Technology Topic 4.2b Timber. And the word timber here refers to wood that has been processed from a tree and essentially is sold to be made into something. It could be made into houses or furniture or whatever. It is a renewable, strong, natural building material with a high aesthetic appeal. It uses less water and less energy to work with, as compared to something like steel or aluminum. But care does need to be given to the use of sustainable harvesting practices to preserve and protect wildlife and the natural environment. These are a couple of cool videos that you should watch. So one of them's the tallest wooden structure and a 3D printed wooden boat. They're pretty interesting. I would also highly recommend that you watch this video. It shows you how timber is milled from a tree, and it's important that you understand that process. Now, wood is a hard fibrous material that forms the main substance of the trunks or branches of trees or shrubs. It can be used for fuel or for timber to build different things. In this case, it's building this bench right here, or this table right here, or this table over here. Wood contains some organic materials. One of them is called cellulose, and the other one is called lignin. And you have to understand that trees need to have something so that they can deal with both tension and compression. So you can imagine that, in the wind, a tree is going to want to fall over, and you need something to stop that tensional force from basically ripping the tree in half. And cellulose is what does that. But you also need something for compression because trees weigh a lot. There's actually a lot of wood in them, but also water and leaves and all those things. And that weight needs to be dealt with. And lignin is a protein that trees use to deal with compression. Cellulose and lignin are difficult to digest. So when trees first evolved, and this is hundreds of millions of years ago, nothing could eat them. They were essentially die and fall into swamps. They're a bit like the plastic of 300 million years ago, where nothing could digest them. And so something that was interesting that happened is that they built up in these huge layers and they got compressed and squished over time, and you end up with coal. And this is a chunk of coal right here. So actually, when we burn coal for electricity today, we're really burning really, really old trees that died in coal swamps hundreds of millions of years ago. I think that's pretty interesting. You can see some coal swamps if you click on this link right here. Now, natural timbers have two forms. They have softwoods and hardwoods. Softwood is the wood from a coniferous or evergreen tree, and hardwood is from deciduous or broadleaf trees. And you can see some different examples right here. So these are pines and spruces, and this is oak, and this is balsa, and I've got a couple other examples just there. Softwoods typically come from coniferous or gymnosperms, and they reproduce using cones. Most have needles. They really like cooler climates. And some examples are pine, spruce, fir, and cedar. Typically deciduous trees, sometimes they can be evergreen, are angiosperms, and they reproduce using flowers and seeds. Most of them have leaves, and some examples of those would be oak and birch, maple, and walnut. Now you got to be a little bit careful about the designation of softwood and hardwood. It doesn't necessarily mean that all softwoods are softer than all hardwoods. It's a bit like me saying that all ants are small, but not all small things are ants. So softwoods generally are softer than hardwoods, but not always. Softwoods have a more simple structure, and you can see that in this drawing right here. Hardwoods have a more complex structure, and you can see that in this cellular diagram right here. We measure the hardness of a type of wood using something called the Jenka hardness scale. And basically what they do is they take a steel ball and they embed it halfway into a wood sample, and they measure how much force is required to embed that ball. And you can see here, these are some Jenka hardnesses for different types of woods. These are softwoods right here, and these are hardwoods right here. But you can see that like balsa wood is quite soft. Its Jenka score is 0.4, and that's less than any of the other softwoods that are on this scale right here. You can see that Pacific yew is quite hard, and it would be down here after this Jara tree before turpentine. But you can see that in general, the hardwoods are harder than the softwoods. And that's something to understand. So it's generally true but not always true. So just be aware of that when you're thinking about softwoods and hardwoods and how they are different. This is a great video, and it shows you how trees, again, are processed, and it's pretty interesting, so I would definitely have a look at that. We need to also consider when we're using natural timbers, think about reforestation. Reforestation is the process of restoring tree cover to areas where woodlands or forests once existed. If this area never returns to its original state of vegetative cover, the destructive process is called deforestation. And you can see this is a deforested area, and basically you would want to replant trees here so that it could look like this again. One of the most important factors when considering natural timbers is they're just full of water, right? Trees basically suck water up from the ground and bring it up to their leaves so they can photosynthesize. And that absorbed moisture is really stored within the trunk of the tree. So absorbed moisture is the moisture within the timber that is contained in the cell walls of the tree. And really, one of the things that we want to do is after we've cut down a tree, we want to get that water out. And I'll explain why that is in a few minutes. I'm going to show you some of the processes, but otherwise you end up with something called dry rot, which destroys the wood. Factors that affect that wood strength are the equilibrium moisture content is a point at which the moisture content of the wood achieves an equilibrium with the environment, which can be affected by humidity and temperature. So we really want to keep wood as we're storing it in a fairly controlled climate. You don't want to have it be doing wild swings with temperature and humidity. Free moisture is the moisture within timber that is contained within the cell cavities and the intercellular spaces. Seasoning is the commercial drying of timber, which reduces the moisture content of wood. And you want to do this so that you don't get dry rot. Now, there's a few ways that we do this. One of them is just to air dry. So air drying places the stacks of sawn timber in an open or in large sheds, hence there's little control over the drying process. So essentially you just kind of stick it underneath a roof outside and it dries naturally. You can kiln dry. So kiln drying places stacks of sawn timber in a kiln to reduce the moisture content in the wood, where the heat and air circulation and humidity is closely controlled. So this is an example of a wood drying kiln. So you're going to heat this up and you're going to dry the wood using heat and controlled conditions. Kiln seasoning is a thermal insulated chamber, it's a type of oven, which produces temperatures sufficient to complete some processes such as hardening, drying, or chemical changes. And this is an example of a kiln seasoning process. And again, you want to do this so you don't get dry rot. So dry rot is when a timber is subjected to decay and attacked by fungus. Fungus is a decomposer, and their job is to go out and decompose wood that's fallen in a forest. They don't really make a distinction between the wood that has fallen off of a tree in a forest and the wood that's in your house. And one of the main ways that they can flourish is when wood is wet. So anytime wood gets wet, fungus can grow on it. When wood is dry, it's more difficult for them to actually grow on the wood. And once wood starts to decay, fungus is going to keep growing and it's going to just destroy that structural integrity of the wood. And you can see this is dry rot here. This is not going to be very supportive in some place like a house. Moisture can also affect the way that wood looks, and we'll get to that in a minute. And another factor that affects wood strength is knots. So knots are essentially where a branch would be coming out of a piece of wood. So you can see them here. These would have all been little branches that would have come out of this wood. And you can see here, this is an example of that. That would be a knot that would be coming out of a piece of wood. Knots are imperfections in timber caused by the growth of branches in the wood that reduces its strength. Knots affect the structural integrity of wood. They make it weaker. And so it's better to have wood that it has less knots in it as compared to wood that has more knots in it. Although sometimes knots have aesthetic appeal. So some people like knots in wood. It just depends on the aesthetics of it. But if it's a structural thing, you probably would not want them there. Once you've cut down a piece of wood, so you've cut down a tree, here's an example of a tree, you need to mill it. And essentially what you're doing is you're cutting it into boards. Now, one of the things that we want to pay attention to is this idea of grain. So you can see that trees have rings, and those rings give the wood a grain. So we talk about with the grain and against the grain. So with the grain would be parallel to the way that the grain is running along the wood. And you can see here, this would be the tree rings right here, and this is the grain that's running along that tree ring. Against the grain is going to be the opposite with the grain, so it's going to be perpendicular to the direction of the grain. When you're drying wood, you have to be careful because you want to avoid warping, which is a distortion in the wood caused by uneven drying, which results in the material bending or twisting. And we're going to talk about 4 types of distortions. So we're going to talk about cupping, bowing, crook, and twist. So let's start with cupping. Cupping is a warp along the width of the face of the wood in which the edges are higher or lower than the center. So you can see here the example of cupping, and we want to try to avoid this with careful drying of the wood. We can see here bowing. So bowing is a warp along the length of the face of the wood, and you can see here it looks like a bow and arrow kind of bow, and the ends of this are going to be higher than the middle. A crook is a warp along the length of the edge of a piece of wood, so you can see that right here. And then of course a twist is when you get a distortion in which the 2 ends do not lie on the same plane. So this plane here does not lie on the same plane as that one there. And you have to be careful about that as you're drying. As I said, moisture content can really affect wood. Changes in moisture content can cause wood to shrink and swell, and also it can weaken it because once wood is wet, it's more open to attack by fungus and insect. And you can see it can discolor wood. This looks like it's got some black mold growing on it. It can cause it to swell. So you can see that's what happened here. This is a wooden floor. It got wet. The wood swole, and then you can see that it's bent up right there. High temperatures can cause wood to lose strength, while low temperatures can make it brittle. This is an example of wood that has been exposed to a high temperature. Ultraviolet radiation from the sun can degrade the lignin in the wood, and that'll make it weaker and more brittle. And you can see that's an example of right here where there's been sun on this part of the wood, but not on this part of the wood over here. And that's going to cause damage to it. And it's going to lose that tensile strength that it used to have. Fungi and insects, these organisms can break down the cellulose in wood, which can weaken it. And you can see that here. These are probably done by termites or carpenter ants. These are wood borers that are eating through a piece of wood. Again, lots of organisms look at a piece of dead wood that's not growing on a tree, as lunch. And so they're going to eat that. Mechanical stress. If you repeatedly load and unload wood, it can cause the wood to fatigue and weaken over time. So this is just an extreme example, but you can see that it's weakening down the center there. Chemicals. If you expose wood to chemicals, it can weaken it. This is wood that has been exposed to salt, and you can see it damages the wood over time.